Hello, everyone, and welcome to another episode from Production Chemistry Minutes. Today, I have a really special guest, Jens Pfeiffer from PSL-systemtechnik, Germany-based company specialized in lab instruments, focusing on the flow assurance testing and flow assurance in instruments. I'm just going to give him the speech. He can introduce his company and the products, the great products they have in there. So the speech is yours, Jens.
Hi, Abdullah. Thank you for the invitation and for the time. As discussed, I will give a short introduction about what we're doing. This is mainly the story about the flow assurance part here. We started 24 years ago now with portable instruments for flow assurance. That was specifically in Eastern Europe. It's difficult to get samples out of the country, and therefore you have to move in with equipment to measure at site. And that was the starting point of the company. And we started with a portable viscometer site, later a portable purport. And this way, step by step, we came to a broad range of instruments. Okay, I'll share the screen now.
Yep.
Okay.
Yeah.
You can see it?
Yeah. Looking good.
Okay. Yeah, well, this is our logo. We use this boy. It's chemistry should make fun a little bit. Yeah.
This is how all the chemists actually look like in the labs. Yeah.
Yes, sometimes it looks like this, and sometimes people behave like this. Yeah.
Yeah.
Okay. Yeah. About our company. This is me and my wife. We are the owner of the company. This was with the Minister of Business, the local one. We had a prize that time. We are working internationally. Oil production in Germany is very, very low. Yeah, you can imagine that for most of our business partners are outside, and still, I'd say the center of oil is still US, Houston.
Yeah.
And this is where we do a lot of work.
Yeah.
We operate as we operate all around the world. We're specialized in giving support almost as well. Everywhere in the world, make a lot of online training, people even doing technical stuff. We have people traveling as well and doing the things that need to be required.
Yeah, that is great.
This is pretty new that we started with third-party testing. Means we had all the equipment all the time, and sometimes people asked us, well, can you do a test for us? And we said, okay, but we didn't make it a business. And now we started to make an official lab where we use our instruments to make third-party measurements. And maybe even more interesting, we can do these custom tests. This means we can design specific test conditions. We can make a specific test because we have all parts here. We have a machine shop. We can modify things if required.
Yeah.
Then I just start with the instruments, just by starting with the VEX.
Yeah, that's it. Yeah.
Yeah. The first of all, the first point of working with VEX is VEX appearance temperature. For this purpose, we have developed a very sensible one. This is using cross-polarization light, means close to cross-polarization microscopy, and therefore is more sensible than other ones. Means the idea that you really measure the onset of VEX appearance, and not the bulk wax appearance with viscometer. And now we're starting to come into the discussion example. Yeah? So it's a real onset where you get the real first crystals, or do you have more wax to use DSC or even a viscometer or rheometer?
Yeah,
Then you
exactly.
get
Yeah,
different results. Yeah, and
yeah,
this
yeah.
one is measuring very, very tiny first crystals already, and it's portable.
Yeah,
That's
yeah. This is actually really great. Like seeing the cross polarized, because it's the ones that people use in different labs. I seen a couple of them, and it's really sophisticated and like needs like specific environment and stuff like that. But having this in portable, this is like a great jump, I would say, in the industry.
yes,
Yeah.
yes. It even have an integrated cooling. Means it uses thermoelectric modules. You just need tap water for counter cooling, and then you can use it at site easily. And yeah, well, this is the first point, and it's you can get it very, very precisely. That's the point.
Yeah.
And then from wax next, and this is one of the really, this was the second instrument we built. We produced it for a long time already. It is a lot in use here in Europe specifically. This is point then, and the specialty is pure point. It's rotational method. It's not that common like E97, but the advantage is it is a continuous measurement. Means the cup is slowly rotating, and you have the temperature sensor. It's off axis, and if the sample slowly, so if it starts chelating and if it gets would start a blockage, then it shifts this sensor that is a pendulum, and this way we detect by light barrier that we reach the pour point, and we have this way we have a continuous resolution of zero point 0.1, and this is very, very important if you start to compare different PPD efficiencies, and you want to be as precise to see if one's better, if you had an effect, and so on. Therefore, this is as well portable. This can be in a carry-on luggage size, going to the field and measuring at site.
Yeah.
From Blue Point, we come to the next wax problem. This is the cold finger. Well, the cold finger, well, in this case now it's wax deposition without shear. The cold finger is pretty standard, even though it's not ASTM method. But everybody does cold finger.
Yeah. All the chemical companies use that. Yeah.
Yeah, and we designed this one with this removable fingers, and the finger sleeves you can measure, and well, this became somehow like an industry standard. A lot. This is the big companies in US and as well several in Canada. They use this setup now.
Yeah, I can see that you can test so many samples in the same time as well, and
Yes, it's up to 15 in one instrument.
oh, okay, yeah,
Yeah, and for cold finger, this makes sense. Cold finger you make run as well as in duplicates, and there are different dosages in duplicates, and you quickly come to a lot of test requirements.
yeah,
Therefore, as well, following the idea of how do I treat an oil, first I measure wax appearance temperature. I check for the pour point. I need to know how much wax will deposit at production temperature. Now, from the idea for the mobile ones is as well a small one for carry-on luggage size for use in the field. A mobile one, just 2 fingers. It's already on the slides here. Actually, we have another variation of this one. This will be not that important for Canada, maybe. It is for lower wax content, if you have more sample amounts. The idea of the original Goldfinger is to use low sample amount. It means you have only 60 to 80 milliliters. So typically, if you're a chemical company or whatever, you get just a limited amount of oil.
Yeah.
But if wax content is very low, then you need more volume of oil. And for this purpose, it is another common design that you use the glass bottles. And here you can go up to 250 milliliters with this and, as well. But it's just, in this case, it's just 6 bottles then.
Yeah.
Special design, now we're starting, this will be next part of discussion, wax deposition. Well, wax deposition Goldfinger should principally be without shear. Means in Goldfinger you have a stir bar, but this should stir just quite gentle, not too much, because with a stir bar, if you stir with high speed, you will see that at the bottom the shear prevents more wax deposition, and the wax deposition gets somehow conical. And the Goldfinger test, some do it wrong. The Goldfinger test should be run almost without shear. The stirring is just to move the sample a little bit. If you want to have shear, then this is a special design. Then you have can have with rotating fingers.
Yeah.
Then you have a Goldfinger where you have can check with different rotation rate and check with shear. And but as well, interesting here, we have shear, but the shear depends on the sample viscosity. This means you cannot, you see a viscometer example given if you want to measure the viscosity, or you want to have a well-defined shear, then you have a small gap. We have a very wide gap here. This means we cannot exactly tell what shear we have. We can just define a lower or a higher shear. It's good to compare results, but it is not running at a well-defined shear.
And if you put the shear at like the very low shear, will this be will this give you results similar to the regular Goldfinger?
No, and this is the reason to measure with shear, means results will vary, and it's not that you can directly tell the percentage is different. This means with the more shear you apply, the less deposition you get. This is a tendency, but some oils are more sensitive to shear and some are less sensitive to shear.
Yeah. I understand.
And therefore, just only having the results from the Goldfinger does not directly tell. This is principally, well, you're on the safe side if you work without shear, but you can. In production, you will have less deposition than on the Goldfinger if you run under shear.
I understand. Like the Goldfinger is made for the worst case scenario.
Exactly.
Yeah. So and the shear will be taken in consideration. Will take some of the deposits out of the Goldfinger itself. So
yes.
The higher the shear, the less the deposits. But that depends on whether the oil is sensitive to shear or not.
Exactly.
Yeah.
And this is where we are coming to this loop test. It means the flow loop test is still, I'd say, this the best test method you can use.
Yeah, exactly.
Because there have a very well-defined shear. You can calculate what shear do I exactly have. You can make the temperature setting, and you're the most close to the field conditions. But you see, with one loop test, we had 15 Goldfingers in parallel. This means we can make a good screening there. You can't make a screening with a wax loop. Means the wax loop typically is just for final testing or for special applications. Means I can use the best products and now put them into the wax loop and see there's different things. A wax loop is very flexible. I can see when does deposition start under temperature and shear. I can see dependent on shear, dependent on temperature. I can as well get information how fast deposition grows, and I get information about how strong deposition or how shear sensitive it is.
Yeah.
And I can run yield point measurements if I want.
Yeah. Yeah.
Therefore, this is a wax loop, and in this case, our wax loop, we again typically we try to have instruments with low sample amounts. This means there's a lot. The big wax loop is a problem. You're often missing of samples. This means if you're not a producer with several barrels of sample, then you need to try to mimic all on in the lab with limited sample amount. This is a very small size wax loop.
I once saw like a wax loop in one of the universities. I didn't see it like in person or something. I just saw a picture of it. It was I remember it was probably Tulsa University or something. They have a flow loop in the size of a hallway. And the piping, like probably, I don't know, probably 2-inch piping and stuff. You can imagine how big the sample size will be for that one.
Tulsa, they have several of these different loops.
Yeah.
I know as well. They have a loop. I think must be about 20, 30 meters, where they can just shift the whole loop, and so the loop goes upwards or downwards, and very, very big fancy stuff, but not for common use.
No, for sure.
Okay, then still for viscosity for waxes, the viscometer, we have a high pressure, high temperature viscometer. This is, well, on the one hand, we are still at waxes to measure at low temperatures. So the viscosity, it can be used as well. Therefore, it's this high pressure range, 1,500 bar. It can be used for other applications like stability of umbilical fluids at very high pressure. Therefore, it was originally built for a deep water field close to Indonesia, where the pressure for the umbilical was very, very high. Therefore, this is just Thermo Fisher viscometer with the software with all the different sensors you can use, and you just run it then under pressure. We made hydrate tests at 700 bar with this as well. This means just a viscometer, but a little bit more flexible than the typical high pressure ones.
Yeah.
Okay, for wax, typically next is asphaltenes.
Yeah. One of the biggest problems in oil field, asphaltenes, and testing them too is really, really confusing and really complex.
Yes, well, asphaltenes in fact are very complex. On the other hand, I think it's easy to understand that it's difficult to describe because the definition of asphaltenes
exactly
is automatically causing a variety of different types of asphaltene depositions.
Exactly. Even the word, like you will see some people, especially in the Middle East, they say asphaltenes, but like in North America they call it asphaltenes. Even the word itself is kind of confusing in pronouncing it.
Yeah, well, with the asphaltenes, what we have, it's a light scattering system. There's different light scattering systems. Typically, you just you can use it as one. You titrate if you want to get height house or whatever, or just the stability, you can, example given, titrate. You can mix what we had as well in customer who mixed his oil with a condensate. Typically in Canada, I think as well, you need some light hydrocarbon phase to remove your heavy oils, and you need to know you could then just titrate with different hydrocarbon and see if you get asphaltene by optical scattering. The challenge was in this case just well, the oil is very dark already, and to get into a very black oil, even see the asphaltenes, and that's where we have a very sensible light detection system here. So the important thing about the asphaltenes is that we can work in undiluted samples, and therefore it can be used for testing asphaltene formation due to pressure for live crudes. And it's important to have more accurate readings. There has been many years ago a PhD study here in the German Petroleum Institute, how big the effect of dilution with toluene or is on the stability of asphaltenes. Means whenever you dilute, you already destabilize the asphaltenes, and it takes days until you're back to normal conditions. Therefore, the idea was here have a very sensible one, so that you can work in undiluted samples.
Yeah. That's actually a really interesting point, because most of the chemicals, whenever you test them in the lab, they fail because in the field. I mean, they fail in the field because of the way of testing. Because most of the time will be on a dead oil, and you add something to precipitate, such as heptane or whatever, and that sometimes this is not actually representing what's happening in the field, but using it on a live crude, this is I think this is a big thing. This is a great feature, because this is what people actually need to, because asphaltene perform like behavior in the field under the operating conditions will be really necessary, because they can change their behavior from lab to field. Even like any change in the conditions can change their behavior. So this is actually I think this is a really interesting feature in the test here.
Yeah. I agree, and in my, I'd say it does not necessarily need to be live. It can be recombination food as well, recombination sample. But example given, just already the CO2. CO2 is very strong destabilizing the asphaltenes.
Yeah, exactly.
Means even much more than N-heptane or N-pentane. CO2 is very critical to asphaltene stability. And if you have, example given, CO2 in the sample already, and in the dead it's out, then you will get completely different results.
Exactly. Yeah, that's not representative. Yeah. Yeah.
Okay, now we come to the hydrates. Hydrates is one of our core business. We have a lot instruments for hydrates. We started with this more well, simple optical cells. It means it's a half-liter autoclave, but it has a camera on the top to view, and this was specifically for kinetical hydrate inhibition to view if some hydrates may have formed. You do not see in pressure drops. Means typically you make QHI testing and you look for pressure drop, but sometimes just a few crystals formed already, and you see this by camera on the surface, and you know, okay, this QHI may have failed or has, and that was one of our early products we started with. Then these days it becomes more and more common. This is the rocking cell principle. So Shell typically uses rocking cell. It's a matter of some people prefer autoclaves for hydro testing. Some prefer rocking cells, and example given, shell very early changed to rocking cells. The rocking cell has advantage. You can quite easily have more cells in parallel. This means here we have example given that's very small. Smaller cells. We have 5 in parallel. Therefore, it's good for screening.
Mm-hmm.
If you look at the results, the rocking cell conditions has very high turbulences. This has effect on the hydrate formation. This means hydrates form more easily, and therefore test methods is principally more stringent than with the autoclave. While with the autoclave, in fact, the results are a little bit more to close to field conditions. Means you have advantage here. You have multiples in parallel. You are on the safe side. In tendency, the rocking cell results lead a little bit to overdose compared to autoclave results. That's
Yeah.
From the rocking cell principle, now we come to a very special design, and this is the full view sapphire rocking cell. This means we are as well using a cell rocking up and down, and a ball traveling up and down, in this way causing turbulences mixing. But in this case, we have a view, this is industrial sapphire. We have a full view to the cell, and we can see what happens inside, all around the cell, and we can measure, we have 2 sensors, and we measure the ball run time. Therefore, it's a little bit like a rolling ball viscometer. This is, I'd say, this is the standard, I'd say, more or less now for anti-agglomerate testing, because for the AAs, you need to see really what happens inside.
Yeah, exactly. Yeah.
And therefore, with this instrument, you see what happens. You have an automatic camera system. You can look what happens in the night, and you can really judge, is it flowing or is it not? And well, this one is 2 cells. This is not good for. This is more for universities. For research, typically in industry, we have this 6-cell benchtop system. We have a 8-cell benchtop system, and this goes up. If you want to make intense testing, this can be 10 to 20 cells. This is the big ones here.
Yeah, that one looks so big. How big is this in a lab? Will it take like a whole block, like a whole wall or something?
Yeah, well, it's like a big table, yeah.
Oh, okay. Yeah.
A little bit bigger than a table, but we even, well, this one, we even have this installed sometimes in a fume hut, but it needs to be a special one. And well, for the hydrate testing, if wanted, you can have all in Hastelloy for Sorgas compatibility. Therefore, then you have to put it into the fume hut, or And the last about the hydrate testing, and this would be again a little bit like typical the way you can make the test in the lab. Well, you use the rocking cell for screening. You have multiple cells in parallel. But this is the difference. The rocking cell you have can only apply limited amount of force to the hydrate slurry, because the ball is just run by gravity. And if you want to simulate how does it run under higher shear forces, if I have high turbulences, high shear forces, then we have we go back again to autoclave. Then we have an autoclave with 3 cameras, one from top, one at water level, one sub-water level, and we can measure the torque of the stirrer. This means we have some of the apparent viscosity of the sample. It means we really can see inside with the cameras, do we have a hydrate slurry? Do we have agglomerations of hydrates? Do we have blockages? And we can recalculate how would be the viscosity of this hydrate slurry.
Yep.
Now we come to water. Well, there's a differential or dynamic scale loop. This is the standard test. This means you only have typically the two tests. You can do a battle test, and this is pretty limited, specifically in temperature. And you have the dynamic test. This means you're pumping typically anionic and cationic brine through a capillary. The capillary is here. This is just preheating. And if you recombine the anionic and cationic, you principally can get scale. And you have a third pump where you can use inhibitor to prevent the scale, and you stepwise reduce inhibitor concentration until you detect the scale by increase of pressure drop over the capillary. The principle is very simple. The important is, in this case, example, it's good to have high automation so that you can run. It's very time consuming, the scale testing. And for special options, you can as well make some tests, like example given combination of seawater with formation water and this stuff.
Yeah.
Means the re-injection. For scale, we have as well a small size mobile one.
I was gonna ask you, did you make a mobile portable differential scale loop, but you actually made one?
Yeah, we made one. Yeah. The small size one, it just doesn't have the comfort of the big one. This means you need to do a lot of more manually, but the principle is again the same. Yeah, you can. And we even have this is the latest development now. We built one for live water testing. This means you can directly go out of the side stream into the system and measure. You can keep temperature, you can heat up, cool down, you can have two pumps, you can destabilize and add an inhibitor at the same time. And you can do all this directly with the water from the production. And this was just released last year.
Yeah.
Now we're coming to the very special ones. This friction flow loop here. This is for testing drag-reducing agents. Means typically the design for drag-reducing agents, it could be shown that viscometer tests do not really work. Therefore, typically flow loop tests are done. But for flow loop, you need, with high turbulences, you need quite a big sample amount. And the problem is that the pump always destroys, with every pass through the pump, the high shear of the pump destroys a part of the drag reducer. And therefore, you could run principally just one dose rate in one run and run with Reynolds number in one run, and then it's done, and then you have to refill, to clean and refill the loop, and this is extremely time consuming. And therefore, what we did here is we use hydraulic drive to drive a hydraulic sample piston of it's just 3 liter total, and but as we are having this hydraulics, you can make even in a small capillary, a small tubing of 3, 5, or 8 millimeters, we can make a very fast flow. with a high pressure drop, so we can go to high turbulences. And this way we can, with the hydraulic, we can make within a flow ramp from low Reynolds numbers to high Reynolds numbers in one run. Means where you would need to make several runs with your loop test. This is done here in about 10 to 30 seconds, one test.
Wow. Yeah.
You can imagine, okay, this is high price. This means it makes sense if you're really screening a lot of products. Then you're saving immensely of time. But, and this is what it's built for. This means really fast screening multiple of products.
Yeah. This is really important too, because most of the time people will have to like choose between a lot of drag reducing agent, because most of them are sensitive to turbulence and the shear and stuff. So if you're gonna give them like a very quick test, that will be a great feature for the chemical companies and the operators as well.
Yes. You can see from the results. Principally, it's not that straightforward. This means the optimal dose rate depends on Reynolds number and dose rates. This means sometimes a higher dose rate does not work better. You have even less efficiency and you really need to look how much turbulence is, what dose rate, and there go to the optimum. This one is as well special design. The principle is not that special. This means it's foam test. You have as well ASTM for foam test, foam stability. It's just in a beaker, you sparkle and you see how stable is the foam. You have the same, you can carry over, means you see, the one is a collapse test. You want the foam to collapse. The other one is if you want to have stable foam, then you run the overflow test, means how much foam does go overflow to the balance, and you can then calculate how much water you could get out of your production line. The specific thing here about is that we go to higher temperatures, that we run under pressure. Because we have been told, we are not in the field ourselves, but we have been told from clients that sometimes if you go to higher temperatures, the product that has been tested in the field at lower temperatures fail. And therefore, that at higher temperatures you need sometimes different products, and that is what this was designed for. We know that we've just sold it to another client. He wants to use it for hydrocarbon. In this case, we made a short test series and could see that in the processing, if you want to avoid foaming of the hydrocarbons, this is as well pretty dependent on pressure. And therefore you can run under pressure. It leads to different results at ambient. Therefore, this is more for the special tests. Now, we come to as well a big problem in Canada, H2S. Well, this one was developed in cooperation with Clariant. They have a patent on a measurement system they use in the lab, and they wanted to have this as a portable one. And we built this so you can go, at least in a big box, you can go to the place you want to measure. As for H2S, moving samples is always very critical. Subsampling is always very critical. You always lose some part of your H2S, and this you can now measure at site. And the specific thing here. It is already built for high temperatures from the beginning. It's up to 150 degrees. This means it's originally designed as well to be used for bitumen products.
Mm-hmm.
And the specific problem about bitumen is if you reheat bitumen and you have temperatures above 100 degrees, 120 degrees, you form new H2S. It's secondary H2S out of sulfur components. This means it seems to be free of H2S, but if you reheat, it's the same with bunker fuels. You can have the problem. If you reheat, new H2S can form. And in this case, you can mimic, you can run at high temperature and see how much H2S does form, how much scavenger do I need to add to measure, to go down to 2 ppm or whatever.
Yeah.
And a little difference than common use measurement of H2S is really measuring in the liquid phase. Means in US and I suppose Canada as well, it's very common to use the CAN test and just looking for the H2S that evaporates from the oil. But if you make risk assessment, the risk is just the H2S you have in the sample. Means like example for ship fuels, if your typical problem, if still H2S is in the ship fuel and the tank is only half full, then you have can get a very high concentration on the top.
Yeah. Exactly. Yeah.
And that's what this one is used for.
Yeah.
And now we come to a final product, and this is as well already starting to get more and more common. That means there's now several companies using this principle. It's for the product stability of injection fluids. Means whatever you inject in your umbilical line, you do not only want to prevent your production line to block, you need as well to prevent your umbilical line to block, because the problem would be the same. Production stops.
Yeah, exactly. Yeah.
And you may only have maybe 3 umbilical lines or whatever, or 2 or
Yeah, it is. Yeah.
And in this case, well, the simple test is just, it's just you put it in an oven, roller oven, and measure viscosity before, afterwards. And this one is making this continuously recirculating the sample through a hot bath, through a cold bath, and in both it's measuring the pressure drop on a capillary. This means the viscosity and the pressure drop on a filter. Means it's you monitor for any viscosity changes or filter blocking. And this you run maybe about a week. And only if all remain stable, then it's a pass. And you can run this under high pressure as well. This means you can make pressure changes, temperature changes. It's a very, very stringent method to ensure that your injection fluids are stable. But it makes sense. Just several years ago, when I installed such a instrument in Algeria at that time, they really had the problem. They lost the well because the injection fluid blocked the well. They didn't manage to get this running again. Therefore, it makes sense to be very stringent here.
Yeah. We had also a case in Egypt long time ago. One of the umbilical lines, we don't know what happened exactly, but they kind of overdosed the chemical down into the well, and that because it was a scale inhibitor, and it interacted with the calcium in the produced water, and that actually made like a inhibitor calcium complex, and that blocked the well. We have to go down the well and do like kind of reperforation or something, or we just have to like, they did a lot of like drilling and stuff down the well because the umbilical line was I don't know what happened exactly, but like kind of overdosed, That's one thing. Also, we had like the gunking or the gunking inside the umbilical lines,
Mhm.
especially in the winter time. That's very common. We have to have like cleaning like program for these umbilical lines from time to time as well. And also with the we had an issue with the wax chemicals, because these wax chemicals themselves, they have their own cloud point. Like when the temperature goes
Mhm.
down, they just tend to like get really viscous and they can clog the umbilical lines as well. And I believe the gas hydrates, probably the kinetic hydrate inhibitors, they also
Mhm.
have like a cloud point as well,
Mhm.
at some point, especially in the wintertime and the very cold subsea and deep water wells and stuff like that. So it's this an instrument will be really handy for the operators and also for the chemical companies as well, because yeah, like you said, if you forgot about the injection, you might lose the well, or you will be like injecting in nowhere, and then it's no win for anyone.
Mhm.
Yeah,
Yeah. Yeah, yeah, and if you just consider what a complex mix of different chemicals it is, so it means
exactly.
you means you have a mix of whatever PPD, corrosion inhibitor,
Yeah,
hydrate inhibitor, and all in
yeah.
one line. That's and then high pressure and temperatures, therefore polymers and it's interesting that it generally runs that good. There could be even more problems, but
Yeah. A lot of the chemicals that we inject are not really compatible. Like you said, the corrosion inhibitor is a big problem with a lot of the chemicals, with the scale inhibitors, with the hydrate inhibitors. They're not compatible at all, and that causes a lot of issues. Yeah.
Mhm. Okay, then we are done with our instruments. Yeah, it's just about what we do work. This This is the instruments we try typically for our instruments is that we use high automation because this is actually to save work time. It means in the past there has been much more people in the lab, and now it's just a few, and they need to run a lot of tests.
And
Therefore,
I see. I'm really surprised with all the features you have. Like I really love the portable instruments that you offer, and you offer them for everything, for the scale, for the wax, for everything. This is really amazing, especially for fields that people have to go offshore and they stuck on the platform because of the weather or because of something. You have to do the test because it's critical, and it'll be easy to do such a stuff. They can use them, take the machine with them wherever they go, and they apply whatever they need to apply, and retest things and make sure the chemicals are applied like perfectly and there's no risk of anything. And you also offer a lot of features like with the shear, the ones with the shear and with the no shear, to like more represent what's going on with the samples and with the field conditions. Like you have different versions from every instrument, which like give the people like more options to choose what fits their condition in the field, and what and their condition with the samples as well. Uh, yeah, so that's really interesting.
yeah. You can do a lot in the lab. Sometimes it makes if you sense to go to the field. Therefore, if you have a problem and you can directly test in the field, this is saving a lot of time. Uh,
Exactly.
uh,
Yeah.
on the other hand, what can be one reason as well? It's specifically the service providers. It's a good marketing instrument. You
Yeah.
go with the instrument, you have a small box of your samples, and you can directly show it works. Yeah.
Yeah. Yeah.
Yeah.
Exactly. Yeah. Yeah. This is what they do. Yeah.
Mhm.
Well, yeah. Well, like flow assurance and instruments are, as I said earlier, it's kind of like a big thing right now in oil and gas fields, because everyone is kind of like pitching in to make sure everything is running smooth. As you mentioned, they are used to assess the risk. to assess the chemicals and see how things will go. Will they be efficient or not? And also, people use them to develop models like the prediction models for waxes. For example, they use flow loops a lot. The same thing for gas for gas hydrates and for the asphaltenes as well. So it's kind of like for multi purposes. And the easier and the more representing for the field, the better will be the results for sure. Like what you just showed me. Um, well, I'm really like excited to see more about your instruments probably in the future, and I really found these instruments really interesting and really amazing features. So thank you for doing this meeting with me today, and hopefully we can talk more about these in more details if you have time in the future. This will be interesting and show people more of the features that you can offer to them.
Yeah, sure. I think this was a quick overview only.
So, yeah,
This was a quick. This means I already told a little bit something about the details, but not just one is about the instrumentation, and one interesting to discuss about is how to define the test conditions, how to run the test, and how to look for the results. And there's a lot more of interest I think we can be talking about.
yeah, sure. And I'm pretty sure I'll be excited to learn more from you, since you are in the field of testing yourself. That means you really understand the problem in depth, and you know what conditions and what factors affect it. So I'll be more interested to learn more from you. I'm pretty sure a lot of people will be also interested in learning a lot from you. So we can actually schedule some meetings in the future. You can like walk us through more of these problems and show you how your instruments do the job, and how important it will be for field and lab testing as well.
Yes, sure.
Yeah,
I'd like to. Yeah.
yeah, sure. So thanks again for this meeting today, and we'll stay in touch.
Yes, we stay in touch.
Okay.
Thanks.